Hello everyone, welcome to my channel. In this video we are going to learn about binomial distribution. Okay, so binomial distribution, it is a statistical distribution. Okay, that is we are going to play with numbers. So it summarizes the probability that a value will take one of the two independent values under a given set of parameters or assumptions. So suppose we are tossing a coin. So what is the probability? So there are two outcomes. One can be, it will be either head or it will be tail. So it will take one of the two independent values. That is an example. And the third point is there is only one outcome for each trial. As I have said in the example, so it can be either head or it can be tail. And each trial has the same probability of success. So this is 50% chance that you will get head or 50% chance that you will get tail. And each trial is mutually exclusive or independent of one another. That is, suppose you are getting head the first time you are tossing the coin. So it is independent, that is there is no guarantee that the next time also you will get head or tail. That is, it is independent. Okay. Now some real life examples of binomial distribution can be like finding the quantity of raw and used materials while you are making a product. Quantity, so it will be a fixed value, right? It will be a one single value. Then taking a survey of positive and negative reviews from the public for any specific product or place. So it can be good or it can be bad, positive or negative. Then by using the yes or no survey, we can check whether the number of persons views the particular channel. So you can or suppose a channel is there, so if you're looking at the channel, then the survey will say yes or otherwise no. Then similarly, the finding the number of male and female employees in an organization and the number of votes collected by a candidate in an election. Okay, so if the candidate is giving vote to a particular party, so it will get the probability will be 1, otherwise it will be 0. Now let us see the formula for binomial distribution. Okay, so suppose we have a random variable x, then the binomial distribution is given by ncx p to the power x 1 minus p to the power n minus x. Okay, so let us see what are these values. So n is the number of experiments that you are going to conduct. Then x is 0, 1, 2, 3, like how many times you want the value to occur. Suppose you are tossing a coin, so suppose you want that the head occurs 2 times, so the value of x will be 2. Then p is the probability of success in a single experiment. Okay, then what is the success that head will occur. Then q, so here 1 minus p, in place of 1 minus p we can write down q. So q is the probability of failure in a single experiment. Then by Bernoulli's trial, this ncx can be written as n factorial divided by x factorial into n minus x factorial. So hence the binomial distribution formula becomes, in place of ncx we will just put this value and then it will become like this. Okay, now let us see one example. Okay, so suppose you are tossing, if a coin is tossed 5 times using binomial distribution, find the probability of exactly 2 heads. So what is the number of n? So according to the problem, the number of trials or n is equal to 5. And what is the probability of getting a head? As I have told, if you toss a coin, there is 50% chance that you will get head and 50% chance that you will get tail. So p is 1 by 2 and q is also 1 by 2. Now you want to get exactly 2 heads. So your value of x will be equal to 2. Now we will simply put this in our formula. So it will be ncx 5c2 p to the power x p to the power 2 q to the power n minus x, that is q to the power 5 minus 2. Now as I have told earlier, 5c2 is 5 factorial divided by 2 factorial divided by into 3 factorial. So you just put it in the formula and you will get 5 by 16. So the probability of getting 2 heads when you toss a coin 5 times is 5 by 16. Now let us see how we can plot the binomial distribution using Python. So first of all, as we will be plotting some graphs, so we will be using import matplotlib.pyplot as PLT. Now we will be using NumPy also, so we are importing the NumPy package as import NumPy as NP. Now we will be using scientific Python, so from SciPy.stats import binom, because we will be importing we want the formula to calculate the binomial distribution. Okay, so these are the packages we have imported. Now let us set the parameters for binomial distribution. So for this, let n equal to 20, that is we will be doing 20 trials. Okay, and let the probability of success be 0.5. Okay, and how many values we are going to generate? See, this we are going to x number of successes. For each of the x values we are going to find out the binomial distribution. So for that we are going to use NumPy to get x values. What are the x values? Starting from 0, we are using np.a range starting from 0 to n. We are writing n plus 1 because n plus 1 is not going to include, it will be only till n it will be included. Why we are writing like this? So that we get the values from 0 to 20. Okay, now probabilities. So for each of the x we are going to calculate the probabilities. So probability is equal to binom.pmf x initially. So we will start from the value of x equal to 0, n will be 1. For initially n will be equal to n is equal to 20. We have given 20. So initially for the first time the probability will be x equal to 0, n equal to 20, and p is how much? We have already said 0.5. So whatever is the answer, the probability of getting 0 success when p is 0.5 and n is 20, that whatever is the value it is given here. Okay, when it is 0 it is nil. Then similarly next time again for x equal to 1 we are going to see. Okay, x will be 1, n equal to 20 and p equal to 0.5. So like that we are going to plot the graph. Okay, so we are going to calculate the probabilities like this. Now we will be plotting the binomial distribution. So we will be showing a bar graph. So plt.bar x, that is from 0 to 20, 1 from 0 1 to like that till 20 probabilities. So for 0 what is the probability, for 1 what is the probability, for 2 like that till 20 we are going to calculate. Align center alpha equal to 0.5. Then we have given the labels plt.x label number of successes, then plt.y label probability, and then the title binomial distribution. Here you see n is equal to, since here we need the integer value, we know that we cannot directly write down the integer value, so we are using dot format n comma p. And grid we have, if you don't want grid you can give it as false. I am giving it as plt.grid true, and then we just write plt.show. So when we run this, so we are getting this graph. Okay, now let's see what happens is now here we have given the probability as 0.5, right? Now let us see what will happen if we change the probability. Suppose there is less than 50% chance that you are going to get a success. Then let's see how the graph looks like. You see it becomes right skewed, that is it is getting skewed towards the right hand side. Okay, so there is high so this is what happens when you are having very less probability of getting success. Suppose you are having, let us give 0.8, then let's see what happens. Now it has become left skewed. Okay, so if it is 0.5 it becomes, the binomial distribution is symmetrical, otherwise it becomes left skewed or right skewed. Okay, so that's all for today's video. If you liked the video, please do like and subscribe. Thank you.